Hello. So on this week's live stream, I've got a guest who's going to actually be doing most of the talking. It's Simon Fels, who is a colleague of mine here at Canonical. He's the engineering manager for the Anbox Cloud team and the project leader for both Anbox and Anbox Cloud, running Android containers on Linux through LXD.
Yes, thanks, Stefan, and welcome everybody. Want to talk a little bit with you today about what we are doing with the product we have here at Canonical called Anbox Cloud. It's a little bit different to the other things which Canonical all do because it has Android in it, and it's something which we worked with in the past, but it's not the primary cloud type of things, but we brought it actually to the cloud. So the Anbox Cloud product has on its purpose to bring Android at scale to any kind of cloud you want. So usually just run Android on a physical device. But the purpose we have here with Anbox Cloud is for all kinds of different new use cases, where one which is really coming up in various ways is like the cloud's gaming one, where people actually start moving games to the cloud and stream the video content back, or just from all kinds of different new use cases, from virtual devices to automation of various applications, or to completely new creative things. So that's mainly what we have developed Anbox Cloud for. And what has it all to do with LXD? So LXD is the main workhouse under the hood. So we're using LXD for all of our containerization. So effectively, we are running Android in LXD containers, which comes with all of the features which LXD has, which means our containers are completely unprivileged. We make use of all of the features which LXD has. We're using clustering under the hood and all of the good things which Stefan and team are putting in here. So that's what we want to go in today, just so that there's a little bit of a better overview of what the stack which we are going to look at looks like. I've prepared a quick overview of that. It should be up now. So that's we have various components in here, where in the center, as I mentioned, we have a LXD cluster, which consists out of LXD worker nodes, where we run all of our containers, which then run a single Android in there. And on top of that, we have various other components which are responsible to handle the streaming, which are handling the orchestration. So we have built an orchestration layer which sits on top of LXD, which is managing all of the Android-specific aspects. So from LXD, you can just spawn an Ubuntu container, but if you want to get more into the Ubuntu container, you have to perform actual installation steps. You have to get something in there. And that's what our Anbox management service, or short AMS, does. So it has that fully automated. It also does, LXD does a bit of that nowadays as well, but we do extensive resource allocation on top of LXD. So we have a pretty clear picture on how much resources for which containers are being spent on which node in the cluster, how much resources on a GPU are being used, so that we can very efficiently schedule containers around in the cluster to achieve really high density and run a lot of Android containers in parallel on single machines. So in the demo I will show in a moment, that are rather small sized machines, but if you just run one of the newer generation server machines, so for example, we're working with Ampere Computing, where they are just releasing their new Ultra ARM servers, which are 80 core systems on a single SoC. So on those systems, you really get to a high number in the 80 to 90 to 100 containers on a single system. So that are all separate Android instances you can run there. And that then really makes a lot of good use of LXD. Yeah, so but there's a bunch of more things which we have here more on the top of the stack, but I'm not going to go into much details of that here, as I mainly want to focus on the lower end. So where are we running Android in LXD containers, and how does it look like? So for that, let me actually switch to my terminal. So that should be up now, right?
Yep.
Perfect. All right. So like, so we have fully automated the deployment of the entire stack with another software we developed here at Canonical, which is called Juju. So in essence, it lets you deploy the entire software stack in a single command. So it's a lot like other tools you may know, like Terraform or Ansible. It has its own kind of way of doing things, but that's what we are using for Anbox Cloud, so that you can very easily deploy the entire stack on a cloud of your choice, which also includes forming the LXD cluster. So by normal, you just have to go into every machine, install LXD, set up the clustering, bring all nodes into the cluster, and then set all things up. With Juju, that's fully automated. So you just say, I want to have one more node in the cluster, and it does it fully automated by also allocating the machine from the cloud of your choice. In this case, it's AWS. Installing LXD on there, and then joining LXD also to the cluster. So that's what I've done here already. So we're running all of this on AWS here. We have S3 node LXD cluster. We can actually just start looking into that from the LXD perspective. So on each of those machines, you have LXD as you know it. So you have a LXD cluster with 3 machines. In this case, because LXD supports that and we support it as well, we have actually like a multi-architecture cluster. So we have both x86 machines and we have ARM machines. So these are the Graviton 2 instances on AWS. And then you have like LXD as you know, like there's nothing much different to how a regular LXD works. Where it gets more interesting from the Anbox perspective, and that's really where we start looking into the Android containers. So as I mentioned before, we have a service we call AMS. So we have the Anbox management service, which is basically its responsibility is to just do all of the orchestration of Android-specific containers on top of LXD, schedule them across the cluster in a very efficient way. So for example, if you launch 5 containers in parallel on a single machine, that might be already too much. So if you would launch another one, the 6th one would get too slow, and our customers are actually depending on very short startup times in the range of a few seconds. So we also optimize the entire startup process for exactly this. Yeah, so AMS, because we like LXD a lot, so we've modeled it pretty much in the same way as LXD is functioning. So it has a command line utility, which is called AMC. So LXD, LXC, AMS, AMC, so we've modeled it in a pretty similar fashion.
Definitely looks familiar.
Yes, like we like LXD does a lot of good things in terms of how the CLI is structured. So like, why should we reinvent the wheel, right? So like, and from here on, like to just launch a single Android container, it's pretty easily. So there are a few more aspects to that, which I can go over in a moment. But I've created a few applications already on here. So we can just launch a container for Android 10. And that just spins up the container on LXD, gets everything going. And once that is done, we type AMCLS and we see there's a container. And then similar to how LXD does it, we go into the container. And we already see like a lot of processes which we don't know from a regular system. So all of these, for those of you who know like how an Android system looks and works, it's not too much like a traditional Linux system. It has its own init system. It has its own way of placing configuration files in the system. It has its own IPC subsystem. So it does a lot different to how a Linux system usually works. But what we are doing in Anbox is we have a runtime around the actual Android container. So we are not just starting the Android container in a LXD container, we're starting Android in a nested LXC container within the LXD container. And we're doing that for the reason of hardware abstraction. So we want to support all kinds of different GPUs from different vendors. And as Android usually has like direct built-in support for a specific GPU model, we would have to ship multiple Android images with support for all of these GPUs. Instead, what we are doing, we have a runtime which sits around the Android container, which then abstracts the access to the real GPU. And that makes it pretty simple for us to run the same Android with an NVIDIA GPU, with an Intel GPU, or with an AMD GPU. And that's also the reason why the first container we are in here, it's just a Ubuntu container. So in this case, it's running Ubuntu 18.04 Bionic. And there we have systemd as normal, like so we have various processes, but the thing which you may already notice at this point, like we're running a pretty stripped down version of Ubuntu, which doesn't have like a debug service. It doesn't have a lot of the other standard services a Linux system has. We stripped that down to just the bare minimum we need to get the Anbox runtime up and running. And from there on, we just spawn a LXD container. So we're just using liblxc here to get the Android container up and running. And that's then like a container on its own, which is nested into the Ubuntu container. And the great thing of what LXC and LXD are doing here, so we have both are fully unprivileged. So like the LXD container, so the Ubuntu container we're running first, is running fully unprivileged with a randomized user ID range. And we're doing the same for the Android containers as well. So like in relation to the Anbox container, the Android container is unprivileged as well. So as LXC and LXD make that super easy, we're making use of that for extra security. Yes. So and then from here on, as we have like, as I mentioned, like we have the Android container nested. You can just get a shell inside the Android system as well. And then you have the usual Android look and feel. You have the Android file system, which I mentioned, like looks already like a little bit similar, but a lot of different. So there are a lot of other things in there. It has different init system and so on. But from there on, it's basically exactly the same as you would expect from a mobile phone, which is running Android and doesn't do anything different. So there's no like stripped down, or we didn't rip out anything from the Android. It's running the pure open source Android as you get it from the open source project, with a few customizations we had to do, because containerization is a thing where you need to handle some things which you do on a physical device need to do differently. Like certain privileges are not available. You can't do certain things because we're running an unprivileged container. So there are a few changes necessary. But other than this, like this is just Android as it's there. So that's yeah. So the other interesting thing which the LXD team worked with us on, and we actually got into the upstream kernel. So Christian Berner from the LXD team implemented this. So there's an IPC subsystem which Android uses, which is called Binder. It's not like dbus, it's different. But if you just want to think of what Binder is, think it's like dbus. So the problem was with Binder before Christian actually implemented something we call Binder FS, is that it was not possible to use Binder inside containers very easily and very efficiently. So because there was basically namespacing for the Binder.
Yeah, like Android originally only was using a single dev binder for the entire system. Then they eventually moved on to splitting that into 3, I believe. Yes. And when they did that, they added effectively support for multi-instance binder in the Linux kernel, but it was very much hard-coded. So like you could choose how many binders you wanted at boot time, but they were global for the entire system. It could never be released. So the work that Christian did along with the Google guys was to first make it possible to actually release one of those things, and then creating like naming them namespace within a file system. Like it's very similar to DevPTS in that you get like a new instance pretty much every time you mount it. And you've got a control device similar to like a loop device control file that you can open, and you get a new binder device out of it. So that's great for containers. That means we can use it unprivileged. It also, all the cleanup we did through that around binder also made it possible for distros like Ubuntu to actually enable binder in the Linux kernel that they ship. Whereas before it was very like very Android specific, using resources even if you weren't using it, that type of stuff. So it wasn't really suitable for a generic distro. So yeah, like I remember that originally Anbox and Anbox Cloud effectively needed you to like use DKMS with like a somewhat heavily modified version of those modules to like sideload them on your system. It worked, but this is much cleaner.
Exactly, right. So like having a file system which is properly namespaced, and Christian did a really good job here. Like that really allows us to have all of those binder devices, and also that in a very efficient way. And I don't know the latest, but I think like Google plans to start make use of that in newer Android versions as well. I'm not sure which devices that arrived on already, but there are changes.
We've definitely seen support for it land in Android proper. I mean, presumably that's what you're using for it to just work. And yeah, often what we see with Google devices, with Android devices, is they don't, like, the kernel never moves really. You get patches, but you don't get new kernel versions usually. So it might, like, I seem to remember that my Pixel 4 doesn't use BinderFS, but it could be like a Pixel 5 or this year's phone. Some of them might already be using it, possibly.
I don't even know if any of the newer Pixel phones even use a 5.0 kernel. I think they might be still all on 4. something. So yeah, and I think like a 5.0 was the first one which had BinderFS. So they may have backported it, but who knows? But yeah, so that's actually was upstream contribution which we contributed because we were working on Anbox Cloud, which is being heavily used here. Yeah, so that's basically the Android container system we have in here. On top of that, as I mentioned before, like we have with the AMS management service, we have all kinds of different functionalities because we want to allow people to very efficiently deal with Android applications. And what you typically have on Android, like for those of you who know how an Android app looks like, you have something which is called an APK. In the end, it's just a zip archive. It's nothing different. So if we just, yeah, sure. Why should it be installed by default? Yeah, so in this case, we have an APK of a very simple app. If you just look at it like a zip file with a lot of files in there, which are making the application, so like a lot of XML files which defining how the UI looks like, the actual code, which is Kotlin in this case, like the Java files, a lot of other things. That's really what in essence makes an Android app. So like it's like, from what you know, like from snaps or flatpaks, it's an archive which ships all of the app in a single package. And we wanted to define a way in Anbox Cloud to make it very simple and very easy for people to make use of those apps. So we've developed a system in AMS on top of LXD, which allows you to do this. So like, if we want to get this application, which is actually a very simple open source note-taking application onto LXD and into AMS, like the first thing you have to do is you have to create a manifest file which defines a few things like what's the actual name of your application. You can put anything you like in there. What's the version? Like that's a free form text field as well. We have something in AMS which we call instance types. So basically just like a simplification to say like how many CPUs and how much memory and how much GPU resources an app should get. In this case, it's just a very small one. So you get 2 CPU cores, you get 3 GB of memory. Every of our containers get 5 or 3 GB disk space by default. I don't recall right now, but not too much as well. So we have proper resource limits in place here. And then all you do is like taking the manifest and the APK, and you send all of that to AMS, and you get the application directly listed. So we see here the application is there. It's now in a state which we call initializing. And that's actually now going through something we call a bootstrap process. So there's a container being spun up for this application, which we call a base container. And what this does now, it basically it takes the standard image we have for Anbox Cloud. It boots up the system, it warms up the caches, it installs the APK, and at the end, it takes a snapshot of the container, creates an image out of that snapshot, and then for any containers which are launched from there on for that application, it always launches from that snapshot. So basically, with that, you can save all of the time you would usually have after you've created a bare Android instance to install the APK, to do any other customizations you may need. You can just start from the snapshot and everything is already put in place for you. So as that process just ran through, like we have the application now marked as ready. So from here on, we can just say, give me a container for that application. And actually, like why it takes now so long is because like that's a specific thing of LXD. So when you create a new image, like the image is first like put into a tarball, and LXD has to unpack that tarball first again. So I think, Stefan, that's one of the things we talked about in the past. We may look into to optimize, but
yeah, and also like if you deploy an existing image on a cluster node that's never deployed before, then it gets transferred onto that node and then unpacked there for the first time around. There are some exceptions to that rule, like an automatic image update in LXD. So if an image is marked as auto-refreshing from a central source, we will automatically unpack it on refresh if the previous version of the image was already onto some specific storage pools. So in that case, we do it in the background to try and optimize the startup process. But if it's the first time, or if it's the first time it's going on a new cluster member, then that needs to get unpacked. There's obviously another workaround there, which is if your storage is distributed. So if you're using something like Ceph, then you will only ever need to unpack it once across the entire Ceph cluster.
Exactly. Yeah, so one other interesting thing. So I think if you have an Android device and you may not have one of the Pixel devices, like the interesting bit is Android receives monthly security updates, and our containers do that as well. So like we publish a patch release every month, getting up to the latest patch release of the security fixes which Google pushes out. So like this is already running on the patch release which came out early December. I think the Pixel devices, I think mine got it like around the 4th or the 5th. I don't recall right now.
Yeah, if you actively look for it, mine only got the automated notification this morning, actually.
So you were not looking for it. I was actually looking for it.
Yeah, I know if you refresh, usually like within the first couple of working days of the month, you usually get the update if you go and refresh. If you don't, then it looks like it can take weeks before the automatic rollout hits your device.
Yes. Like, so that's one thing which we do with Anbox Cloud as part of our commercial offering as well. Like you get those latest security updates so that your containers always have those in, so that you don't run behind like some devices out there, like they run years behind. Like if they even run an old Android version, like completely unpatched with, and I think like what Android or Google fixes like roughly every month is like at minimum 20 CVEs. So like a lot in the media stack, but also a lot of on things like Bluetooth and other things. So there's quite a few things every month which are getting fixed.
Yeah, I suspect a lot of those are not particularly relevant for Anbox actually, but yeah, it's definitely good to keep on top of them.
No, like we don't have Bluetooth support, but all of the media stuff, all of the core system stuff, they are all essential, right? It also depends on like your exposure, right? So like we have different modes in Anbox Cloud of how you can run an app. So you can run an app in something like a kiosk mode, so where you don't have access to the rest of the system. So the exposure you have to the system is very minimal. So in order to cause any harm, like it's limited. But if you have full access to the entire Android, it's different, right? It's like there are those different angles where this makes sense. Yes, so that's basically about the containers. So like there's a lot of neat things about the containers as well. You have standard CLI interface. Actually, I shouldn't have deleted those. But let me just spawn another one. Why the one above here is going away. Yes, we have all of those things which you know from LXD as well. So you can even you have the exec command. You can follow live the logs from the container. You can invoke any other command. Our REST API we have under the hood actually looks pretty similar to how LXD does it. What else is interesting to show here? Yeah, so I mentioned that in the beginning. So we have in AMS, we have a pretty good idea on the resources each node has. So LXD lists all of those nodes, but we add them into our database as well. And on top of that, we actually get from LXD like how many CPU cores, how much memory a node has. So like in this case, I think this is a G4DN X large from AWS. So it has 4 cores, 15 gigabytes of memory, and it has an NVIDIA T4 GPU. So we have something we call GPU slot, which basically is just a simple way of dividing a GPU into multiple portions so that each container gets one portion of it. And then on top of that, we do something like overcommit. So because none of the containers will ever utilize all of its CPU time it has assigned. So we give our users the ability to like define overcommit rates so that you can actually like make more out of your system with keeping in mind you're still bound to what your system physically provides. But in terms of the CPU time each of the containers has available, you can overcommit that to then make better use of your available resources. And that's basically what AMS knows about all of the machines. So we have that for all 3 machines we have here in the cluster. And it uses that in its scheduling process to like just get things scheduled on the right node. We also have different strategies so that you can spread the containers around the cluster. You can bin pack them so that you load one node first and then you start with the second node. So
I mean,
all of
am I
that.
reading this right, that you're showing the same resources on the ARM64 Graviton as you do on the Intel right now?
Yes, it's the instance type is similar. So I think this is an M6G X large as well.
Mm-hmm.
So like that's correct. The only thing which is not correct here, which
Yeah, the GPU is a bit different.
that's a bug. I just saw. So that's actually not
like
right.
you're using, you said I think NVIDIA T4s or something on the Intel ones, but obviously on Graviton you don't have any dedicated GPUs.
So the LXD2 one is an G4DN X large. With the LXD0 is the same, and this is an M6G X large. Yeah, so this is actually not correct here. Like this is automatically set. But yeah, bugs can be fixed. Yeah, so that's basically the container level. The other thing I think it's worth showing here, because that's where a lot of work happens in Anbox Cloud as well, is the actual low latency real-time streaming we're doing on top of this. So for that, let me bring up. So this should be now live, right?
Yep.
Right. So like we have a very simple web UI that's currently being replaced with a newer one, but it basically runs in a web browser. We also have SDKs so that you can write native applications for Android, Linux, later on Windows and iOS as well, but currently just Android and Linux. But in the web browser, it works perfectly fine as well. So you can stream any of the applications we have on the cluster currently running. So if we look here, this is the application we've just created before. So we can define like what the screen format should be. So should it be 720p, so HD with 60 frames per second or 30 frames per second? Let's pick 30 here. We can define like, do we want to have portrait or landscape mode? And then we can just get the visual output in a video stream streamed live from the LXD container and just use the app as normal. So if you look at this, like this just looks like a standard Android app. You can work with it. You can add you can add new items to the app, and you can just work with it as with any other Android app. I shouldn't have done this because this is another feature we have. So basically, this invokes when you want to share something on Android, you basically invoke another app. And in the standard mode we have in Anbox Cloud, you're not allowed to do that. So if we detect that your app is actually trying to open another app, we forcefully shut you down. So in terms of security. So we can just
that's the kind of thing that like you can, if there's a strong need for like a specific customer to do something about it, like you could trap that. You can like have it call an API or do a bunch of fancy things as needed.
Yeah, exactly. Like the standard we have right now is like you just get kicked out, but you can fine tune this and say, yeah, I'm fine with launching another app. I'm fine with as long as it's specifically this app. So like we are pretty flexible in what happens at that point.
Because like here, you could presumably, someone could build an app presumably that's got effectively like on their web page has a list of all the stuff that's been shared, and when you click share, you only have like one sharing target, which just dumps it back into their API if they want, or something like that. Like
exactly.
That's a good thing of having control on the Android build and having that intermediate containers that you can actually trap a bunch of things like. I know that in the past you've done things like trapping location request, for example, or yeah, looking at some other things like I don't know, camera or any other sensors. You can kind of do whatever you want there.
Yeah, exactly. Yeah, so under the hood, like I will show a few other apps where this gets more exciting. Like this is just a standard notes taking app, but I think it just shows what is possible. So under the hood, for the actual streaming, you be using WebRTC, so the very same protocol you use on Google Meet, for example, on Microsoft Teams. So all those communication services which are getting more and more common. I think Zoom doesn't use WebRTC. They have their own crazy protocol to do communications. But like all of the other ones, they're using WebRTC as well. Even those game streaming services, which are getting more and more popular, like Google Stadia or GeForce Now from NVIDIA, they are using WebRTC as well under the hood as a protocol to get a video stream from a remote endpoint to your local browser or your local app. So we are using the same protocol here under the hood. And at the top, you see a little bit of the statistics for this very simple app here. Like there's not much changing on the screen. So we have 30 frames per second. We have like very low bandwidth because like there are no changes on the screen. So like every frame is pretty small. Like the actual round trip time, because it's an AWS data center, which sits pretty nearby. It's like we have like 15 milliseconds on average. So like 7 milliseconds to the data center, 7 milliseconds back. So this is pretty neat for just doing like working with your app, doing things with that, and so on. Oh yeah, this invokes another app as well, so I shouldn't have clicked that. But what do I wanted to say? Yeah, so like the protocol, like we've did some optimizations in WebRTC to make the streaming more efficient and specifically optimize it for the low latency case, because for this simple note-taking app, like latency is not too much of an issue. Sure, you want to click and you want to see a reaction, but it's not like a game where you have very low latency targets. So for that, let's try this game. So that's actually Bomb Squad, which is a game we have from a game. Sorry, I need to use landscape mode for that.
And doesn't support portrait.
It forces you into landscape when you launch it. So yeah.
I guess that makes sense. Okay. A game like this played vertically would be a bit weird.
Yes, like you would like rotate your phone, right? You just move your phone around and then you have it like we have landscape mode. Like here in this case, because we don't send an event through from the server side right now. Okay, we are in landscape, please rotate the video stream. So that's purely nothing you do. You have to select that up front. Yeah, so let's take. Yeah, so this is actually like a game we have from a partner, from a game publisher. So it's Bomb Squad. So it's basically like a game where you run around, you throw bombs around, you're trying to not fall from a platform. And right now I'm not playing it right now. It's running in an automated mode, which we use for stress testing. So we usually, like when you run a lot of containers in parallel, it's rather hard to like pause actual gameplay on all of them. So what we do is using this automation mode to simulate user gameplay and then have like actual feedback on how good the performance is. So, and here we see like
I just give a quick disclaimer that like this is running on Simon's system over Google Meet, then streamed to YouTube. So obviously any kind of like frame drop or extra latency or compression artifact you're seeing is not actually there in the original. You can see at the top right that it is actually doing 60 frames per second just fine with low latency. And obviously the bandwidth has gone quite significantly up because you're streaming a full screen at 60 frames per second.
Yeah, we're streaming 1080p, right? So like that's actually like, but I think that gets more visible if we look at this. Yeah. So like we stream that game, it's coming through, it's running 60 frames per second. And we can actually now exit that mode and I can play myself as well. And it actually reacts to my reactions if that comes through the stream quite well.
So how good are you at playing games now through all of your day job?
You could say, yeah, but like there's a lot of stuff happening under the hood, right? Like usually what I do is just bring always the same type of actions in these games because I explicitly want to trigger certain behaviors. Yeah. Yeah, and then the last one, so we can actually like get a pretty standard. What do we pick here? Let's pick 720p. We can get a pretty standard Android system streamed as well, which just gives you the standard experience of how you know an Android system. So you have a launcher, you can pull it up, you can go into settings.
I guess one thing that will probably jump at some people is that looks like a bit old as far as Android looks. But that's because a lot of what makes the current Android look and feel is all of the Google apps, which you can't legally install on like random systems. You need to have like a Google certified platform to be able to install the Google Play Store and all the Google apps. So that's why like the Android open source project, which is what's used here, still shipped with some of the older widgets that you might remember from years ago, despite it being the latest Android version. Well, or even not the latest.
The very first days, like if you look at this search app, like that looks like the very first Android versions from ages ago, right? Like this metal type of style of doing the UI that's long gone from Android. But like as we are just building Android as it comes with the open source Android project, that's still what it builds to by default. Like, and as Stefan said, like all of those standard things, from Android, the experience which Google delivers or which other partners are delivering are either what Google builds on top of this. So you can very much see the Android open source project as a framework everybody else uses to build something different or to differentiate themselves from others. But that's the base line everybody builds on top of.
Yeah, and if you really wanted this to look like modern Android, there's nothing preventing you from installing a modern launcher, install, Firefox and some modern apps instead of the built-in AOSP ones.
Oh yeah, totally. Like you could do that. Like there's nothing preventing you from doing you even have a phone app in here. Like that's basically all the apps which come standard with Android. Yeah, and I think that's more or less it what I wanted to show today. Yeah, I think in summary, like so we're running Android containers. Like you can run a really high number of Android containers with the containerization we have done on top of LXD in parallel on a cluster of a bigger size. So customers are actually looking at cluster sizes of like multiple LXD clusters of a size towards like 40, 50 nodes, which would give you a capacity like of running a few hundred to thousand like simultaneous Android containers all streaming to end clients. Whereas like other use cases we have as well is like just somebody wanting to automate an app for all kinds of different use cases. And we directly since the beginning wanted to have Anbox Cloud as a product which lets you do all of that. And we just don't stay in your way. We provide you the baseline you can work with, you can build on top of, and then implement your product, your dream of what should come next onto the market. And that's it from my side. Or Stefan, do you have anything else?
Yeah, it's definitely quite interesting to see what someone can build on top of LXD cluster and some of the features we've built over the years. It's definitely a very interesting solution. I mean, I think we mentioned it a couple of times now in the stream, also because we keep referring it as a product. So this is obviously that's not an open source project. This is a commercial solution that customers can get from Canonical. It is like a lot of the components are based from open source projects or derived from open source projects. Like Anbox itself was, well, still is an open source project, which has now, like, it's a way customized version that's actually running inside of Anbox Cloud to run the container itself. But the open source project is definitely still there. If all you want to do is run a few basic Android containers, Android apps on like an Ubuntu desktop system, you can still use Anbox for that. This is dual LXD integration layer and scalability and APIs and streaming and everything is really the extra solution that's there for customers. It's quite exciting. It's also kind of interesting, like all the different things you can do with it. I mean, the game streaming is obviously usually the most high catching one of them. Like it's always fun to see game streamed over the internet with like minimal latency and things being quite a lot of fun to play. But like there are a lot of interesting use cases for this kind of solution. I mean, we've seen in the past. It can range from companies wanting to do CI type testing on their Android apps. It could be companies wanting to test simple things like how does my email render in every single Android app that can read emails, or in all the different web browsers on Android, or on the same web browser on all the different versions of Android. Like there's a lot of that kind of stuff you can do, and those don't require that much as far as hardware resources. Then you indeed have things like game streaming. Like there's a lot of interest in that. 5G is reducing latency to consumer devices quite a lot, making this kind of stuff much more viable than it might have been in the past.
Yes, absolutely. That's where a lot of interest is where that's now, right? And the other thing which LXD allows us to do very efficiently as well, like we scale through different architectures. Like Android naturally like comes from the ARM space, but Anbox Cloud like doesn't really make a big difference because like containers just run everywhere. So we're building our container images for both x86 and ARM as well. So you can run on ARM, you can run on x86, you can mix that in your cluster as you like to. And if then an app just requires specific Android instructions, then you can just run that on, sorry, not Android instructions, ARM instructions, you just run it on an ARM machine instead of an x86. So
yeah, and there are like I mean, those can apply for like generic companies and end user type cases, but there are also potentially interesting applications for like restricted environments, like whether it's like a government agency, healthcare system, or any other type of military contractor or whatever, any kind of company where
right.
you do have data that's confidential, that you want your staff to be easily able to access, interact with, use their apps and everything while they're on premise, while they're working, but you don't necessarily want to have to maintain a very large set of dedicated machines for that. This kind of lets you do kind of the best of both worlds, where you can use like a bring your own device type system where people can come with their normal phones and stuff. You can provide a streaming environment either for just the apps you want or for the entire desktop within like your Wi-Fi network or like a local 5G cell or something on like within your buildings. And as soon as the person is out, they no longer have access to any of that data. So that gets them the convenience of using their own device kind of the way they're used to. There's no like need for training, for device management, for keeping track of assets and everything. But you still keep pretty much full control as to the data and the applications.
Right. Yeah, a lot of people are seeing like game streaming like as one of the number use cases for this, but like what you just described, that's a lot more what a lot of people are looking for nowadays, because like we all have a smartphone these days, right? So like we have a lot of data on there, personal data, but we also start to mix and match like company apps in there, like having access to company chat systems. Like, and if you can clearly isolate those things away on a separate device, which is physically bound to your smartphone, but you could even use that from different phones. Like that moves you in a totally different direction, right? Which adds a lot of benefits to such a solution.
Yeah, and I mean, you also have the ability technically of like detaching the session, like reattaching it on different devices if you want. Like you could totally have your set of corporate applications running on your phone, then moving that to a tablet, moving that to a desktop. Like the same session can be reattached. You might get into some funny corner cases with like the aspect ratio and resolution and stuff, but like that does let you decouple things. Like you could restart your phone and reattach the exact same session, and that'd be fine.
Yeah, exactly. And you would still have all the data at the same location. Like I think for other use cases where, for example, for things like games, why things are moving to the cloud is also like one of the underlying reasons, like having better network connectivity at the backend. Where it's like usually like people have games have to deal with all of the network connections for synchronization when you play online games and so on. That can now be way more efficiently handled on the backend on a cloud. And the only thing a user really depends on is just getting the video feed, providing input back, and everything else can happen very efficiently under the hood, right? So yeah, like this, it has a lot of advantages to just move things for different use cases to the cloud. But also like for Nbox, what was very important for us since the beginning was that we built this not like as one solution, which covers just one use case. Like we made this from the beginning, as we do it with a lot of other things here at Canonical as well. We made this more like a framework. So like we give you the building blocks. We give you the building blocks in a very secure, stable, and tested way, so that you can build your product on top of that, and you don't have to worry about all of those little details, like how do I do low latency video streaming. And that's actually pretty attractive to a lot of people, because that's usually where there are not much knowledge of how you do those more advanced topics. Like it's the same for containerization, right? But low latency video streaming is a topic on its own. of how you do that very efficiently, and then also integration with GPUs, how you do serial copy, video encoding, and all of these things. So that's really what we wanted to solve here for our customers to allow them to implement on top of.
Yeah, the other thing that's maybe worth mentioning is that while it's got cloud in the name, and the demo was definitely using cloud instances, and we can run that on any kind of public cloud. It doesn't have to be. It's definitely possible to run that on any kind of physical hardware that would be on location. That's specifically, again, quite important for some of those cases where you want to provide a secure set of desktops applications. You can totally run that directly in your building. Kind of like LXD cluster, you're probably going to want at least 3 systems just so that things can be pretty reliable. And then choose whether you want GPUs or not. If you want ARM systems, then I hear that Ampere is doing quite good machines there that can definitely be used for pretty high density ARM workloads on premise.
Yes, that's in the end, the only requirement we have is you must run Ubuntu. You must run either Ubuntu 18.04 or 24, both are supported. And then you must run on either x86 and ARM. But beyond that, you can deploy on any of the clouds which Ubuntu supports, which ranges from all the major public clouds to even on-prem deployments where you have something like MAS, Metal as a Service, to orchestrate your data center very efficiently. You can even deploy everything onto a single machine. So if you just have a box sitting around in your lab, you can even deploy onto that and just run everything from there. You can run with GPUs, you can run without GPUs, we have support for that in our containers, that we auto-detect what kind of GPU you're running with. And then we load the right implementation for either NVIDIA GPUs, AMD GPUs, or Intel GPUs. Or if none of those is available and you still want to stream, it's not the most efficient way of doing it, but we can even do software rendering and software encoding, and that's then our fallback if none of the GPUs is available. And that, so the node stacking application we have seen earlier, that was actually running with software-based rendering and software video encoding. So from a cost perspective, that's interesting for a lot of people as well. If you just run such a simple app, you don't really need GPUs. You can just survive pretty well with just doing everything in software if your app is just not constantly changing the screen, and the actual work which is being done by the renderer and by the encoder is not too high. Then you can perfectly survive without a GPU and save quite a good chunk of costs.
Okay, well, to wrap it up, I guess we can just mention that if folks are interested, Anbox Cloud, you can get more details on anbox-cloud.io, and the open source project, if you're interested in just running some Android apps directly on your desktop and don't want any of the LXD plus orchestration layer and all that stuff, you can look into Anbox itself, which is anbox.io. And for clustering on LXD and stuff, you can always go look at our website and forum. We've got quite a lot of people doing interesting clustering things there too. Thanks for that. Thanks for the demo. I think it was quite interesting. Definitely a bit different than what we had before on this channel, but it's great to talk to people actually consuming LXD instead of just us producing it. So thanks for that. Thanks for your time. If anyone has any more questions or whatever, leave them in the comment section. We'll keep an eye on. And otherwise, that's going to be the last stream of the year, I expect. So enjoy the holidays and catch you all in 2021.
Yes, thanks, Stefan, for that and for having me here today. And enjoy the break, guys. Have fun and stay safe.
Bye.
Bye-bye.
Okay, well done.